I thought that I would go ahead and make a video of the warm-up problem from November 11th. These would be your solution stoichiometry and titration notes 8.7, because it never hurts to have tons and tons and tons of step-by-step redox balancing examples. So we're going to balance the following redox equation in acidic and then basic solution. Our initial reaction is Fe2 plus Cr2O72 minus, that's the dichromate ion, becoming iron 3 plus chromium 3 plus. The first thing we need to do is assign oxidation numbers and identify our half reactions. For several of our species, this is pretty easy. The iron 2 plus, iron 3 plus, and chrome 3 plus all have the charges of their monatomic ions. For the oxygen in the dichromate, that's -2 because oxygen is one of our keystone elements. It's almost always -2. We can use this to figure out what's the oxidation number on the chromium in the dichromate. The sum of those oxidation numbers has to add up to the charge on the ion, which is -2. There are 7 oxygens, each worth -2, and 2 chromium atoms present. So if we crunch down that algebra, we find that the oxidation number on chromium has to be +6. Now we're going to compare the oxidation numbers across the reaction to identify our half reactions. We can see that our iron goes from +2 to +3. This means that that is our oxidation half reaction. The oxidation numbers are becoming more positive, therefore iron is losing electrons. We can also see that our chromium goes from +6 to +3. It is our reduction. It is gaining electrons. And remember, the electrons that the iron loses are being absorbed by the chromium. That is why we have to have paired redox processes. The next step is to balance each half reaction separately. Let's begin with our oxidation. Iron 2 plus to iron 3 plus. The iron is already balanced, and there's no oxygen or hydrogen, so we're pretty much set there. We just need to balance the charge. And we do that by adding an electron to the product side, so that the overall charge on both sides is +2. Next, let's look at our reduction. So first we need to balance the chromium. We're going to do that by putting a coefficient in front of the Cr3+. Next, we need to balance our oxygens by adding water to the oxygen deficient side. 7 oxygens, 7 waters. Now that we've got water in the equation, we can balance our hydrogens, and we're going to do that by adding H pluses to the deficient side. We've got 14 hydrogens in our products, so we need 14 H plus on the reactant side. Now lastly, we're going to balance the charge. We've got, 14 plus -2, so 12 plus total charge in our reactants, and only 6 plus total charge in our products. Therefore, we need to add 6 electrons to the reactants to balance the charges. Now we can multiply one or both of these half reactions by a coefficient to balance the electrons in to the electrons out. Then we add them and we eliminate them. The easy way to do this is to multiply our oxidation by 6. That way we've got 6 electrons out, 6 electrons in. If we do that, we get 6 Fe2 plus becomes 6 Fe3 plus 6 electrons. Now we can add and eliminate. We're going to eliminate the electrons, but we get to keep everything else. Therefore, our final equation is 6 Fe2 plus aqueous plus 14H plus aqueous plus Cr2O72 minus aqueous becomes 6 Fe3 plus aqueous plus 2 Cr3 plus aqueous plus 7 water liquid. Now you can go ahead and do your idiot check to make sure that I've balanced all my elements and all my charges correctly. The other note here is that H plus is always going to be aqueous in these sorts of equations, and water will always be liquid. It's our solvent. So now that we've got it balanced in acid, let's balance it in base. To do that, we're going to begin from our balanced in acid equation, and we're going to add hydroxide. Then we're going to form waters and eliminate. So looking at our balanced equation, we've got 14H plus over in our reactant side. This means that we need to add 14 hydroxides to both sides. So now we've added 14 hydroxides to both the reactants and the products. Now we need to look for H plus and OH minus that are on the same side. And we can see that we've got that right there in our reactants. We're going to smash those together and turn them into water molecules. So now we have 14 water molecules in our reactants. We need to compare the water on both sides in case we need to eliminate some. And we do. There are 14 in the reactants, 7 in the products. So those 7 products are going to go away. Our final expression will be 7H2O liquid plus 6Fe2 plus aqueous plus 2Cr2O7 minus aqueous, becoming 6Fe3 plus aqueous plus 2Cr3 plus aqueous plus 14OH minus aqueous. And again, you can double check that I've done my work correctly. So there you go, one more redox example problem. I'll see you guys in class.